Welcome to this explainer. Today, we're diving straight into the mind-bending theoretical physics of time travel. We're taking what is arguably the most famous science fiction dream of all time and treating it as a tangible, fiercely debated scientific pursuit.
So, the ultimate question, right? Can we actually build a working time machine? Well, we're going to explore exactly how these devices could theoretically operate, sticking strictly to the established laws of physics, while also tackling the massive, brain-breaking logical hurdles standing in our way.
To really understand this, we have to start with a surprisingly emotional core. Meet Ronald Mallet. At just 10 years old, his father tragically died of a heart attack, and this devastating loss sparked a lifelong secret quest. Young Ronald essentially vowed to become a theoretical physicist for one reason: to figure out how to literally change the past and save his dad.
Okay, part 1. Time physics, Einstein's relativity.
Before Albert Einstein came along, scientists assumed time just ticked away at exactly the same rate for everyone, everywhere. But Einstein completely flipped the script. He proved that time is actually highly flexible, and it all rests on two incredible pillars. On one side, special relativity tells us that moving incredibly fast actually slows time down. On the other side, general relativity shows that massive gravity does the exact same thing. So speed and gravity, those are basically your keys to hacking the clock.
To really wrap your head around special relativity, just think of the famous twin paradox. If one twin blasts off in a rocket at near light speed, they literally age slower. When they finally return to Earth, they'll be significantly younger than the twin who stayed behind. And hey, this isn't just theoretical math on a chalkboard. It was actually proven back in 1971 when super-precise atomic clocks flown in supersonic jets were checked, and they ticked measurably slower than the exact same clocks sitting on the ground. Wild, right?
Let's put some numbers to this. Imagine you're traveling at 285,000 kilometers per second. That is a staggering 95% the speed of light. If you blasted off on a deep space mission at that mind-bending speed and came back in the year 2032, you would be 22 years younger than everyone you left behind on Earth. You essentially just time traveled right into the future.
Which brings us to part 2, Mallet's optical time machine.
Look, human space travel at near light speed is, well, entirely out of reach right now. Our fastest rockets don't even come close. So, Dr. Mallet designed a completely brilliant workaround for reaching the past using light. He proposed an incredibly elegant three-step process. First, light itself can actually create gravity. Second, as we just learned, gravity bends space and time. So, step 3, Mallet mathematically proved that a circulating ring of intense lasers can create a gravitational field strong enough to twist space and actually fold time on itself into a closed loop.
But here's the kicker. Mallet's machine doesn't transport actual human beings. You can't physically step into it. Instead, it acts like a temporal tunnel for sending binary data into the past. It uses the spin of subatomic neutrons. So a spin-up neutron equals a 1, and a spin down equals a 0. Just like your laptop, this creates binary code. If you send a sequence like 1, 0, 0, you've just sent the number 4 back in time. Imagine using that to warn people of an impending disaster.
All right, moving on to part 3, Frank Tipler's massive cylinder.
Mallet isn't the only physicist with a blueprint. Professor Frank Tipler proposed a totally different, almost unimaginably massive design. To make his concept work, you'd need to build a cylinder 100 kilometers long. And the catch? It would need a mass equivalent to our entire sun. It has to be unbelievably dense, compacted, and spinning at absolutely extreme speeds. The idea is that it would warp space-time so intensely that you could travel backward in time simply by walking around it.
But hold on a second. What happens to all that crushing gravity? Survival is kind of a crucial point here, right? The gravity from an object this impossibly dense would likely crush you completely flat before you could even attempt to use it. So yeah, the engineering here is literally as deadly as it is complex.
Let's look at part 4, travel barriers and paradoxes.
So, assuming we don't get squished by a sun-mass cylinder, what are the actual, real-world barriers preventing us from building these machines right now? First up is the staggering financial barrier. Building a full-scale, working version of Mallet's optical machine would cost roughly $10 billion. To put that into perspective, that's comparable to the massive CERN particle accelerator over in Europe. It is an absolutely monumental undertaking.
Furthermore, there's a deeply tragic limitation baked right into Mallet's math. You can never send information to a date before the machine was officially activated. If you turn it on in December 2015, someone in 2030 can send a message back to 2016, but never to 1955. Meaning, heartbreakingly, Dr. Mallet can never actually send a warning back to save his father. The loop only goes as far back as its moment of creation.
Part 5. Will we time travel? And overcoming skepticism, because history is full of skeptics who said things like flying were impossible.
Ultimately, even if we completely conquer the physics, secure the funding, and build the hardware, we still have to wrestle with the legendary grandfather paradox. If you travel to the past and accidentally prevent your parents from meeting, how could you have ever been born to build the machine in the first place? It's the ultimate logical loop. It really makes you wonder, if we ever do figure out the engineering, could one tiny mistake completely erase your own existence? Now that is definitely a thought to leave you with.